Associated with every non-quadrantal angle in the standard position is an acute angle called its reference angle. A reference angle for an angle theta written as theta prime is the acute angle made by the terminal side of the angle theta and always the x-axis. Now, reference angles are always positive and are between 0 degree and 90 degrees. So say for example, if we look at our first figure here, theta in quadrant 2. Theta here, we know that for our angle to be in quadrant 2, it must be that its angle measure is more than 90 degrees but less than 180. Okay? So it means that for our reference angles, kinahanglan lang we will calculate how much more angle is needed for our given angle to be 180 degrees. So say for example, let us say for this case, our theta is equal to 120 degrees. How many more angle is needed para mahimo siya nga 180? Because again, since our reference angle is always measured from the x-axis. And so for this case, for our 120-degree angle, it needs 60 more degrees para mahimong siya nga 180. So therefore, our reference angle for 120-degree angle is 60 degrees. Now, let's say for our second example, which is our theta now is in quadrant 3. But if you can observe, for our angle to be in quadrant 3, it must be greater than 180 but less than 270. So this time, we will ask how much angle ang nisobra from 180 degrees. So say for example, this is, we have our theta to be 200 degrees and it is 20 more degrees than 180 degrees, di ba? So it means that our reference angle for 200 degrees is 20 degrees. Now for our third picture here, which is theta in quadrant 4, we know that for our angle to be in quadrant 4, it must be greater than 270 but less than 360 degrees. So therefore, instead of referencing our angle to 180, this time, ato na siyang i-reference sa 360 because it is provided in here that your reference angle must always be positive and that it is also between 0 and 90 degrees. So for our third illustration here, if we reference our angle from the 100, the the negative x-axis, this here is more than 90 degrees. So we don't want that. Ang ato yung himon is reference angle between 0 and 90 degrees. Now, a common error is to find the reference angle by using the terminal side of theta and the y-axis. Dili jud. It must always be from the x-axis. Now, you might be wondering why. Ano man yun sa X, ganun dili man sa Y. Now, take note that at the very start of our discussion in trigonometry, when we defined angle, we say that our angle is in standard position if it is measured with reference from the positive x-axis. So, dira magsugod sa x-axis. So, the same lang po na siya nga analogy that since our angle is with respect is measured as in standard position, which is from the x, and then its vertex is at the origin. So ato pong i-reference ang ato ang angle sa x-axis. either positive or negative x-axis. So if we, based on these definitions, yeah, let us do example 6. Find the reference angle for each angle. Letter A, 218 degrees. Now for our 218, letter A, if we can observe, 218 is more than 180, but less than 270 degrees. So therefore, we will calculate our reference angle with respect to the 180-degree mark, which is from the negative x-axis. So that is, let us say theta is equal to 218 degrees. So theta prime, which is our reference angle, is equal to 218 degrees minus 180. So our reference angle, which is theta prime, is equal to 218 minus 180 is 38 degrees. Now, later on, we will know nga kung sa medyo importance, yun ang kinahanglan pa man na tubalon ang reference angle. So, letter B, we have 197 degrees. So theta is equal to 197, and 197 is more than 180 but less than 270. So we will start our measurement from the negative x-axis or at the 180-degree mark. So that is theta prime is equal to 197 minus 180. So our theta is equal to 17 degrees. Sorry, theta prime. Next. Letter C is 1,387. So of course, based on this, 1,387 is more than 360. So what we're going to do is we will find the lowest positive coterminal of 1,387. And in order for us to do that, we will subtract 1,387 we will subtract 360 from 1,387 multiple times, or we will follow the equation that we had, that is 360. If 360 times 2, that's 720. 360 times 3, that's 1,080. 360 times 4, that's 1,440, which is greater than our given 1,387. So therefore, 1,387 degrees minus 360 degrees times 3. So our theta, which is coterminal to 1,387, which is the lowest positive coterminal, and that is 360 times 3 is 1,080. 1,380 minus, sorry, 1,387 minus 1,080 is 307 degrees. And 307 is more than 270 but less than 360. So we will reference or measure our reference angle from our positive x-axis, and we will use 360. So theta prime is equal to 360 degrees minus 307 degrees. So theta prime is equal to 360 minus 307, and that is 53 degrees. So you might be wondering, nga 360 then padulong man dira. Wait, if this is 360 and let us say this is 307, ana, then dili ba ing ana ang pag-measure nato? No, wala ging ana nato ang pag-measure nato, di ba? If clockwise measurement, that is negative, no, where pag-measure nato is from here padulong dira. That is why 300, unahon na itong 360 minus 307. And for this case, 218 and 197, so most likely na sila dira, right? So mo ni ang entire 218 ba? So from here padulongan na counterclockwise gud ang ato ang measurement para always positive ang ato ang reference angle. Okay, and to summarize it all up, the preceding example, which we did, example 6, suggests the following table for finding the reference angle theta prime for any angle theta between 0 degree and 360 degrees. So which is, if our theta is in quadrant 2, theta prime is 180 minus theta. If our theta is in quadrant 3, so our theta prime is theta minus 180. And then for quadrant 4, theta prime is equal to 360 minus theta. And of course, if our theta is in quadrant 1, that is positive. So theta prime is equal to theta. Since we have calculated the exact values of our 30, 45, and 60 degree angles, we can now find for the exact trigonometric function for these values. Let us do this example 7. But before that, finding trigonometric function values for any non-quadrantal angle theta. So for quadrantal angle, that is 90, 180, 270, and 0 and 360, right? So the first step would be if your theta is greater than 360 or if it's less than 0 degrees, then it is best to find for the coterminal by adding or subtracting 360 as many times as needed to obtain an angle greater than 0 but less than 360 degrees, which we did sa letter C, example 6. And after that, we find the reference angle theta prime, the smallest positive from 0 to 90 degree angle. And next would be find the trigonometric function values for the reference angle theta. And step number 4, determine the correct signs for the value found in step number 3. Use a table of signs given earlier in the text or the paragraph above if necessary. And what this refers to is this one. Kani. We know that if in quadrant 1, our x is positive, y is positive. For quadrant 2, y is positive, x is negative. Quadrant 3, both are negative. And quadrant 4, negative y and positive x. Let me put these in parentheses. Okay, so knowing that, let us do example 7. Find the exact values of the 6 trigonometric functions of 210, 135, and 240. So although it says the 6, we'll just do uh 3, the basic 3. Sine, cosine, and tangent. For letter A, we have 210 degrees. If theta is equal to 210 degrees, so theta prime, if you can observe 210 is greater than 180, but less than 270. So therefore, 210 degrees minus 180 degrees. So our theta prime, which is our reference angle, is equal to 210 minus 180 is 30 degrees. Now, sine 30 degrees is equal to 1/2. Cosine 30 degrees is equal to square root of 3 over 2. And then tangent 30 degrees is equal to square root of 3 over 3. Right? Now, what this means is that if the reference angle of our 210 is 30 degrees, what this means is that sine of 210 degrees is also 1/2. Sine of, sorry, cosine of 210 cosine of 210 is square root of 3 over 2. Tangent of 210 is equal to square root of 3 over 3. However, we are still missing one thing. Now, if we try to graph 210, like I said, 210 is more than 180 but less than 270. So the location of our 210 is at quadrant 3. Now, if we are in quadrant 3, your y is negative, your x is also negative. So, for our sine 210, wherein sine is very much associated with our y, so sine is negative 1/2. Cosine 210 is negative square root of 3 over 2. And of course, your tangent 210, if we have a a negative numerator and a negative denominator, our final answer would be positive. So that is why tangent 210 is equal to positive square root of 3 over 2. Now, if you want to check, you can always press sine 30, and that is 0.5. But if you input sine 210, you will have negative 0.5. If you input cosine 30, of course, positive 0.866025403. But if you input cosine of 210, that is negative 0.866025403. Because again, your 210 degree angle is in quadrant 3 if it is measured, ano, see, again, it is under the assumption that this angle is measured from the positive x-axis because all angles are measured from there kay kuan man siya kanang in standard position. So 210 is in quadrant 3, and in quadrant 3 both x and y are negative. Next, 135, letter C. Letter B, sorry. Letter B, 135. Theta is equal to 135 degrees. So theta prime is 135 is more than 180, is more than 90 but less than 180. So therefore, this is 180 degrees minus 135. So our theta prime is equal to 45 degrees. 45 degrees, right? And sine 45 is equal to square root of 2 over 2. Cosine 45 is equal to square root of 2 over 2. And tangent 45 is equal to 1. This means is that, what this means is that for our sine, since our sine of an angle is very much associated with the y, and since 135 is more than 90 but less than 180, this means 135 degree angle is in quadrant 2. And in quadrant 2, y is positive while x is negative. So sine of 135 degrees is equal to square root of 2 over 2. Cosine of 135 degrees is equal to negative square root of 2 over 2. And tangent of 135 degrees, since our tangent is sine over cosine and sine is positive while cosine is negative, so we will end up with negative 1. So to check, if you have your scientific calculators with you, sine of 135, you simply input sine 135, you will have 0.707106781, while cosine 135, that is negative 0.7071 0.06781, and tangent 135 is -1. Okay, so for our letter C, 240 is somewhat the same with our A, but of course, they will not have the same value, but the signs will be, algebraic sign will be the same, since 240 is greater than 180, but less than 270. So sine of 240 will be negative, cosine of 240 will also be negative, but tangent of 240 will be positive. Next, example 8. Let us have this sa next video na lang kay taas na.